Hi. In printing, there is a couple of settings that are very important to what you will get in output quality, but are never fully explained. So we're going to try and do something about that, and we're going to discuss the settings for rendering intent and BlackPoint compensation. Now, these are both more advanced topics, so if you haven't seen the Color Basics video, I recommend that you first take a look at that. If you obviously are familiar with color management and just want to see what I have to say about this, feel free to watch. But if you don't, and if you haven't seen anything on color management, this will strike you as confusing and complicated. So let's start with an image. Now, an image like this is a test image that I actually use on printers. And this little test image can tell me a lot about the color behavior of a printer. And I have a couple of details which I'd like to point out here. It has a standard gray bar, that's fine. It has a gray bar in selected patches, so it has 25 different levels of gray. And at the bottom here are the most important one for one of the settings. It's a gray level that goes down from RGB values 46 to RGB values 1. So that's RGB 111. Now these are important because these values create the biggest problem when we try to print. And let me explain why by going to this file in Photoshop. So let me minimize this one. I'll close it. If we open the same file in Photoshop, it's exactly the same file. If we then go to image levels, we can see that this image has a lot of pure black in it, which is going to be hard because even though this is an sRGB image, let me show you that, convert to profile, you can see what kind of image it is. It's an sRGB image. Even though it is sRGB, the darkest color you can create within an sRGB file, just by clicking on here, is RGB 0. If I go to the information menu and then click on the same value, you can see it's lab 000. That means it's absolute black. Now that is going to create a problem when we print, because no printer, no printing press, no device whatsoever will be capable of displaying lab color 000. You just will not be able to see. Just like I on this display cannot see luminance levels lower than something like 13, 12 here. Any value like that, lower than that. It's not because my eye cannot see it, but it's just that's the blackest black that the screen can make. And it cannot go any blacker. So this is a luminance value of 3. So that's blacker than what I can get in print. Because trust me, you cannot get black level 3 on a print. You will be unable to get that low. So the problem is that we need to have the black compressed in order to not lose details. Because if we don't, we will lose details in black. And the easiest way to show that to you is just by going to the print interface from Photoshop. But it can do the same in any other application. So Aperture and Lightroom, you can do a print preview and you have the same effect. So I'm going to say print. And what is important is that you have your color management set to Photoshop manages colors. Because if you let the printer manage colors, you won't be seeing what the effect of the profile is. So you don't see what the limitations of your paper are. Now in this case I'm going to choose a cheap paper on a good printer with 12 inks. So a printer with a good color range, just a paper type that doesn't really have a lot of quality, just a 90 gram paper. Now if I look at the settings below the printed profile, there is rendering intent, and there are 4 options available: perceptual, relative, or saturation, relative, and absolute. Within Aperture and Lightroom they made the absolute and saturation disappear because they're frankly not much used in photography. because the absolute colorimetric is one that is used to take into account the color of the paper you're going to. Because if you're going to print on newspaper paper, that's going to be gray or yellow or pink or whatever color paper. It's not going to be pure white. So if you want to create a print on your printer, taking into account the paper profile's color, then you have to simulate that color with a profile by using the absolute color intent. So in most photo applications, the choices are limited to relative and perceptual. Now in perceptual, there is no BlackPoint compensation, so you can choose it, but there's no need, because perceptual, by definition, does BlackPoint compensation. So what does BlackPoint compensation do? Well, it's quite easy to see if we switch to relative. Relative and BlackPoint compensation, we still see the gray bars that we have here, the dots, the gray dots, we still see. If we switch off the BlackPoint compensation, we don't see any details here. Why? Because our printer is not capable of producing a black that black. So it stops at a level above RGB level 46 by its blackest black. That already is the blackest black that it can make. It can't go any lower than that. So I can show you that in the profile. So I'll switch to ColorThink, and ColorThink is an application that enables you to compare profiles. So what I'll do is I'll open up two profiles, one being the cheap one, installed user profiles, that cheap paper, and the other one I'm going to do is the sRGB one. So that's a system one, or a reserved one, sRGB. There. Now as you can see from the top, looking at the A and B axis, you can see that the gamut of sRGB is much bigger than this plain paper. And that's not the only problem, however. So if we then use something here which is called slicer, we can actually go through all of the luminance values of the profile. So we have a luminance axis that's straight into a screen here, and if you go up, you get to the lighter colors in luminance value. You see the colors go lighter, and if you go down, you get to the lower colors. And this actual slider here goes from 0 to 100, which is the luminance range of the LAB model. So this is pure white, and this is pure black. Would be nice if we could print it, but in theory, in practice, we cannot. But it is there, as you can see, it is there in the sRGB color range. So if we switch off the sRGB and then take the slider up, we have to go up quite a bit, up to here, so level 23, before we can actually see something. So any luminance value below 23, we cannot print. So whatever profile you have, if you look at the LAB color of your image and it's below 23, forget about printing it on this paper. It's not possible. But within our profile, the sRGB, it is there. So if I rotate the image to 3D, and then switch them both on and switch off the slicer, and then switch it on again, you can see that all the colors below here, these are all colors that are within the sRGB range, but I can never print on this paper. Why? Because if I look at the paper itself, just the paper profile, and then move my slider up, that's where my black starts, from that cheap paper. So at 26 I've got some choices of color, and as I go further up I get to the bigger range of colors, up to around 50, which is a normal point to have the biggest color range, and then it goes back down again as colors become lighter and more towards the absolute white point. So this is how you can see that the actual levels that I can reach in luminance is fairly limited, because I cannot go above 93 and I cannot go below 23. So maximum luminance range is quite small, and our sRGB luminance range, if I compared it to, goes from absolute 0 to, rotate it, absolute white. So that means I can never ever print sRGB on any printer, on any device, because it will not allow me to do RGB or lab 000. So we need to compensate for that, and we do that within Photoshop by using the BlackPoint compensation and rendering intent. So let me get back to Photoshop. So let's hide this one. Oh, it doesn't have a hide. Why not? Okay, that's hiding. So back to Photoshop. Relative colorimetric, I lose all my detail in black. And if I click on BlackPoint compensation, what actually happens is that all the darker colors, all the colors towards black, are simply compressed upwards in the LAB model, so they become visible again on the paper, because now you can see there is a difference between 46 and the black. And if you scroll to the left, you can see still details up to 24 RGB. So that means in effect that any color I use in this image, if I want to print it on this paper, if I use any color below RGB 24, I'm not going to be able to see it. So that means in my levels, right, say OK to this one, I go to my image, adjust levels, and please apologize the Dutch version, it's just the version I had. If you look at levels, 23 is quite a lot. That is a lot of black you are not supposed to use, or you will lose it in detail. So in effect it means that you have to lighten your image, like we're doing here. Lighten your image like that so you don't lose the details. And if you don't, you will lose the details. It's not a defective thing about the printer, it's just it cannot reach those colors, and it's got to do something with dark colors. So it needs to compress all those colors, and by compressing it, we just go to a lighter range. So why not stick to the range that you know you're going to be able to reach, so you get colors the way you see them on screen, instead of having a big color range on screen and then printing it on a profile that has a small color range. So that's about the BlackPoint compensation. Now the other setting that's there, if I go to print, is instead of relative I can go to perceptual. And perceptual actually decreases the entire gamut of my print, because it doesn't just lift the black, but it also makes sure that all the saturated colors that do not fit within my destination profile, so in this case my plain paper, are compressed so they do fit inside the paper profile. So I don't get a saturated red, green and blue as I would in relative. That is why most people prefer to use relative with BlackPoint compensation. But if you have really saturated colors, and your colors do a transition from a saturated to an even more saturated color that a printer cannot reach, then you got a problem, because your color transition will just stop, and it will be the same color for the last part of it, which will not look nice. Now in other applications, so let me hide Photoshop, like Aperture for instance, if you go to print from Aperture, you have exactly the same choice. If I do not say crop, but I keep the entire image, then here in rendering I have again the choice to select a profile. So this is again my cheap paper, and if I choose relative colorimetric without BlackPoint compensation, I lose a lot of detail. You can even see it on screen here better than in Photoshop, that you lose all the colors here, because this is all black. And that's what would happen on the printout. You'd have a lot of black. 1/3 of your image is black in this case, of the tonal range. So you don't want that. You want details, so you want to use BlackPoint compensation, at least, so you have more of a gray balance here. But still I lose a lot of colors here, so I'd be smarter to adjust my image so I don't get to a black as image as this, because it would be too black. Although I can see those differences on screen, I will never be able to print them. Now, the choices you have in rendering intent within Aperture and Lightroom are limited to perceptual and relative. Why? Because proofing is not something you do from an application like Aperture or Lightroom. That's more something for Photoshop or InDesign. Those are proofing capable applications. Lightroom and Aperture are photo-based applications which just take the most logical choices for photography into account with perceptual and relative. So you do see the difference in perceptual. You see all the colors go lighter. If I go back, even the red becomes lighter. All the colors become lighter. And the fact that you have a BlackPoint compensation here within perceptual is actually a bug, because there is no BlackPoint compensation, because perceptual just makes your entire source profile fit within your destination profile. So it compresses by default also the black. So just switching this on or off in perceptual doesn't make a difference. In relative, it's a big difference, because it's the difference between seeing no dots here and seeing the gray dots here slightly with relative, with BlackPoint compensation. So not an easy topic to grasp, but important if you want to know why your images lose detail in black. So I would say make sure that you know what you are going to be printing on when you're adjusting your image, because if you know that the output media you will be using has a fairly limited BlackPoint, then try not to use that BlackPoint in your image, because that just needs to be compressed. And if you can do the compression yourself and still make the rest of the image look well, you'll be better off than just handing over a huge file in color range and have the printer compress it, because they will very likely compress all the other colors in a way you don't want, or they will just lose colors or detail. So that's it for rendering intent and BlackPoint compensation. This is a topic more complicated. Feel free to ask me any questions on it. Hope it was useful, and thank you for watching.